Okay, so we'll discuss what is linearly independent vector set. Okay, say you have a set of vectors like v1, v2, dot 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 up to, let's say, vn. Okay, now if you can write say alpha 1 v1 plus alpha 2 v2 plus dot 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 alpha n vn equal to 0. Okay, once again 0 is a vector. Okay, if you could come up with some set of alphas, okay, for a given vectors, okay, then we call this as linearly, sorry, yeah, dependent. Okay, so one obvious solution is put alpha 1, alpha 2, alpha 3, everything 0. Okay, then irrespective of whatever this v1, v2, v3, it's always going to be 0. So that's a trivial solution once again. Okay, so the alpha 1, alpha 2, alpha 3 should be such that it should be a non-trivial solution. Okay, or in other words, at least one of the alpha should be non-zero. Okay, then we can call this set as linearly dependent. If you don't have any such non-trivial solution, then you can call that set as a linearly independent vectors. Okay, okay, so now let's say mm, okay, 1 0, that's v1. Okay, and then 1 1. Okay, are they, so this is a set v1 v2, are they linearly independent or linearly dependent?
They are linearly independent.
Linearly independent. Okay, so you cannot come up with some alpha and beta, so that, okay, fine. So now what about this one?
Linearly dependent.
It's linearly dependent because say if this is v1 and this is v2, so yeah, v1 1 into v1 plus minus 2 into v2 is equal to 0 vector. Yeah, so for that reason it's a linearly dependent. Okay, sorry, yeah, it's a linearly dependent. Now the previous problem, when the vector is linearly independent, what was the previous set? 1 0 1 1. Okay, with these two vectors, were you able to cover the R2 space, the entire R2 space? Which means by using a linear combination of this v1 and v2, can you reach any point in R2 or any point in xy plane? So just recall what we have discussed, how to reach a point.
Yes, sir. Yes, sir,
We can reach any point. Okay, so that's the one of the property. Okay, so if it's a linearly independent, okay, then
it forms a basis.
it forms a basis, right? And also we can reach any point in R2. And one more thing, what I wanted to say is something called span of a set of vectors. So what's a span? The span is, say for example, you have a set of v1 comma v2 comma dot 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 comma vn. Okay, what are all the vectors you can obtain by doing a linear combination of these vectors? Okay, then all the possible uh, output vectors are the span of these vectors. So for example, in this case, okay, so v1 and v2 are the set. Okay, with this set, the span of v1 and v2 is r2, because we can reach any point. So
Yes, sir.
all the points are a span of this v1 and v2. Okay, now let's come to this thing once again. Okay,
Yes, sir.
v1 and v2, where v1 is 2 2 and v2 is 1 1. Okay,
Yes, sir.
now tell me, what is the span of this vector set? So can you reach any point in R2 space?
No, sir.
You cannot.
Yes, sir. Only you can reach certain points.
Okay, so can you tell what points we can reach?
0 0 we can reach.
Yeah, 0 0 always we can reach if you put 0 as the, I mean, for any set you can reach, right? Okay,
3 3 we can reach.
3 3 we can reach. Okay,
5 5 we can reach.
see, now let's say alpha into 2
2
2
2
plus
beta
beta into
1 1.
1 1, right?
Yes, sir.
And that's equal to 2 alpha plus beta, 2
2
alpha
alpha
plus
plus
beta, right? So which means the x component and y component has to be same. I mean, if there is a point where the x and y component are same, then
we can
I
reach
can
that.
reach that point, right? So which means in this xy plane, I can reach the points when x is equal to y,
Y
which means
along a straight line.
along this line I can reach. Okay, so which means this is the basis. So all these points in this line is the basis of, sorry, not the basis, the span of these vectors.
Depend
These
depending on
vectors, yeah, but they are dependent to
to
each
each
other.
other.
Okay, right. So so what are the concepts we have discussed? Once again, we'll just do a revision. One is called
Inverse.
basis. Inverse we have discussed the last video. So one is called basis.
Basis, span.
So basis, span. Okay, so what is basis?
Basis is a set of vectors.
Set of vectors.
Yes, sir.
Hmm?
Which can reach through any linear combination
Hmm.
the entire R2 space.
Okay, it's not necessary that it has to be R2 space. Okay,
Okay.
say there is some space. Okay, and
Any vector
uh,
space.
yeah, any vector space. Okay, we haven't gone into detail about what is
What is
vector
vector
space
space?
and all those things.
Yes,
That
sir.
we will come later. But so there is some vector space. Okay, and say the basis is such that a minimum set of vectors where the span of those minimum set of vector is the which will cover the entire
Entire space.
space. Okay, then we call that as a basis.
Basis.
Okay, and the span is like for a given set of vectors, what are all the
Possible.
possible output or outcome or the linear combination, all those collection are called the span of
Span of
that set of vectors.
yes, sir.
Okay, so this will conclude this video.